Okay, we're continuing 7.4. In this video, we're going to talk about case 1, distinct linear factors. So our objective remains, throughout this sequence of videos, to integrate rational functions where the denominator, q, is a product of some combination of linear or quadratic factors. Here specifically, we're talking about the first case, distinct linear factors. So let me show you in full generality what we're talking about in terms of the decomposition, and then we'll do a decomposition as an example, and then we'll do a full example where we actually carry out the integral. Actually, we'll do a couple of those videos, a couple of those examples, showing a number of different techniques, but this is the objective, to integrate these functions. So, first, we'll suppose q of x is a product of distinct linear factors. And here's how I'm going to write that. Warning, new math notation coming right up. So I'm going to draw what basically looks like a uppercase pi symbol. Okay. And notice that the subscript says I equals 1, and the upper script is a k. So this is similar to summation notation in that we have a dummy variable I that's running from 1 through k, 1, 2, 3, 4, and so on until we reach k. It could be some number, who knows what it is. And the form of the things that we're iterating is a sub I x plus b sub I. And what this notation is saying is we're multiplying them. So in other words, this is a product. And so when the same term repeats but with some minor variations, like in a sum, we can express it in shorthand using the product sign. So in other words, what we're talking about is a sub 1x plus b1 times a sub 2x plus b2, parentheses, dot, 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 all the way up to a sub k x plus b sub k. Okay, the a and b number, the a's and b's here are just numbers. Okay, so that's why these are linear. Then the method of partial fraction decomposition says there exist a sub 1, capital A sub 1, capital A sub 2, dot, 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 capital A sub k, such that p of x over q of x, regardless of what p of x is, as long as the degree is less than the degree of q, is equal to the sum of these rational functions. So the a sub 1, a sub 2, those are all numbers, okay? Just like the little a, b, and the little a's and the little b's. In other words, we're breaking this down into a sum that is easier to work with because here's the payoff, right? So when we do this, that means the integral of this thing will just become a1 times the integral of dx over a sub 1x plus b1 plus a sub 2 times the integral dx over a sub 2x plus b2, and so on. And these we can integrate because we just need to perform a simple use substitution, and we'll be able to pull out, it'll be the antiderivative will be a sum of logarithmic functions. So it'll look like a sub 1 times 1 over a1 natural log of a1x plus b1 plus capital A sub 2 times 1 over a2 times natural log of a2x plus b2, dot, dot, dot. Don't memorize this part. because working with the actual integral that we're going to get, you'll see how this comes out anyway. So it's not a really super helpful formula here that I'm writing, but that ends up being basically the full form of the integral now that we've split it up using the partial fraction decomposition. So the stuff that I've written in red so far is basically the payoff, what we get from transforming a question of integrating a rational function into integrating simpler rational functions and using the natural log rule for integrals. Okay, so the hard part here really is finding the a. So our task in the intermediate steps is find a sub 1, a sub 2, a sub 3, so on, a sub k. Okay, and these are real numbers, right? All right, so in this next example, we're going to go through a decomposition. So example, decomp, simple linear, so distinct linear factors. So we're going to start with, we're going to decompose using the method of partial fraction decomposition. X minus 6 over x squared plus x minus 6. Okay, so some key things here. First, our p of x is x minus 6 has degree of 1. Okay, it's linear. Q of x, on the other hand, being x squared plus x minus 6, can be written as, if we decompose it, right, we're actually going to factor it, is x plus 3 times x minus 2, and is degree 2. So we don't need to perform long division here of the polynomial parts, but we do get two linear factors, okay? So we have x plus 3, so linear, and x minus 2, linear. And they're not repeated. They each appear only once in the factorization. Okay, so that's the first step. We're going to factor q of x. So step 1, factor q of x. And we already did that, so we're done. This means we need to find, and I'm not going to usually use A1, A2 as the uppercase letters that we're going to have to solve for. I'm going to use, in alphabetical order, capital A and capital B, which are real numbers, such that x minus 6 all over x plus 3 times x minus 2 equals, now this is where we're actually going to use the method of partial fraction decomposition. Remember that we said that we can break this down into two terms, the first one being a over x plus 3 plus b over x minus 2. And what this does is it's going to allow us to write out this fraction simpler. And then once we are concerned about integrating, then we'll find the integral. But for now, we need to find this capital A and capital B. Okay, so the question is, how do we do this? Okay, and you'll notice that what we're starting off with here, our equation star, is a rational equation, and we'll convert it into a polynomial equation by multiplying by the we're going to multiply by the least common denominator. Okay, so in this case, it's just going to be multiply both sides by x plus 3 and x minus 2. And you may be wondering, at this point, we are just sort of performing the we're just doing algebra, so why would this need, oh geez. Okay, it's saved. Phew, that would have been really bad. Okay, you may be wondering why are we focusing on performing, just the algebra? We know how to do this. And the thing is, I know that you know how to do this, but since we're going to be doing it so often, we're going to develop some techniques to do it quickly and effectively, okay? So, fundamentally, these are skills that, if you're coming out of intermediate algebra, you would know. But we're going to practice them and hone those skills here because they're going to be so essential to getting these integrals done right, okay? So, we'll do some nice cancellation here, assuming that x is not -3 and x isn't 2. That basically turns this equation into the numerator, x minus 6, equals, and then if we, actually carry out the distribution here, notice we got x plus 3 times x minus 2 times a over x plus 3. So the first term, the extra 3's will cancel, so we'll just get a times x minus 2. And in the second term, the other factor cancels out. So in this case, we get x plus 3, okay? Now, there are a variety of techniques that we can use here. And the first one that we're going to use is we're going to, just follow our nose here and keep working. And we're going to get a nice system of two equations with two unknowns. Our unknowns, by the way, are a and b, not x. Okay, so x is just kind of just along for the ride. And you'll notice here that what we're really doing is we're setting up this polynomial equation, and there's a tip here, a trick, that if you have a polynomial equation, you can set up separate secondary equations for each power of x. What we mean by that is on both sides here, right? So we have an x term. So we have x terms here, ax and bx on the right side and x on the left side. And we have constant terms, so like the -6, the -2a, and the 3b. I'm going to highlight those differently, actually, so that we see here. The ones that I underlined once are going to go into their own separate equation, and the ones that I highlighted twice are the ones going into their own separate equation. So that ends up looking like x equals ax plus bx, and -6 equals -2a plus 3b. Now, in the first equation, you can cancel out the x's. We don't need that anymore. So really this turns into 1 equals a plus b, and -6 equals -2a plus 3b. This is a linear system of two equations and two unknowns. And you can solve this however you want, okay? So at this point, we don't really have a hard and fast technique, really. You can use substitution, you can use elimination. Those are standard Math 120 intermediate algebra techniques. In later videos, I am going to show you some more sophisticated techniques, okay? And I'm not going to hold you responsible for knowing those, but you are going to see them later on if you continue in your STEM studies. So it'll be helpful for you to see them, at least get some exposure here, okay? All right, so what we'll do here is I'm going to use substitution. So basically, I'm going to replace b by solving for it in the first equation. So b equals 1 minus a, which means in the second equation, we get -6 equals -2a plus 3 times 1 minus a. And what this will give me is an equation in just a. So I get -5a plus 3a on one side and -6 on the other side. And what should I get? Does that look right? Okay. Then if I subtract 6 from both sides, I get -9, -5a. Did I mess somewhere? Did I mess up somewhere? X minus 2, x plus 3, This looks right. Okay. And so what we see then is we have A. A is 9 over 5. So A equals 9 over 5. And then B is, we said that was 1 minus A. So 1 minus 9 over 5 is negative 4/5. Okay. So those are our two missing variables, which means then our solution is this rational function is going to turn into let's see, A goes in the numerator for x plus 3. So we get 9/5 over x plus 3 plus negative 4/5 over x minus 2. Okay, not bad. And you can write this more simply as, you can write it out as 9/5 times 1 over x plus 3 minus 4/5 times 1 over x minus 2. All right, so that really is this is the decomposition. This solves that task. And it's now our goal to actually put this into some examples where we're actually going to carry out an integration. Okay, but we'll say that for the next video.